Find the limit as x approaches infinity of e to the 1 over x power minus 1 all over 1 over x. All right, so first thing we usually do is just plug in this number, right? Okay, so as x approaches infinity, so let's see what we get when we plugged it in, right? We get e to the 1 over infinity minus 1 all over 1 over infinity. Okay, now of course, 1 over infinity, remember we're talking the limit, right? So as x approaches infinity, right, e to the 1 over infinity it's like 1 over infinity is like 0, right? So e to the 0 power is 1, so we get 1 minus 1, and then once again 1 over infinity, pretty close to 0, right? So we get 0 over 0. This is an indeterminate form. Okay, so once we've determined that this is an indeterminate form, we can go straight into L'Hopital's rule, right? We'll take the derivative of the numerator divided by the derivative of the denominator. Okay, and we're still taking the limit as x approaches infinity, of course. Okay, but what is the derivative of the numerator? So let's just write that out. E to the 1 over x minus 1, right? Well, this part just goes to 0, right? It's just a constant. But what about the derivative of this? Remember, this is an exponential function, so the derivative would be, right, if y equals e to the u power, then dy dx equals e to the u times whatever that derivative is, right? The derivative of the exponent. Okay, this is by the chain rule. So the derivative of this then would be e to the 1 over x, it's just that exponential function, times the derivative of 1 over x, right? Well, that's just negative x to the negative second power, right? Assuming, converting this into x to the negative first power. Okay. So that's what the numerator becomes, right? We get e to the 1 over x times negative 1 over x squared. Okay, we'll just write it like that. What about the denominator? Well, actually, the denominator we've already done, right? What's the derivative of 1 over x, right? That's x to the negative first power. That's actually just negative x to the negative second power. All right, so the denominator just becomes negative 1 over x to the second power. Hey, wait a minute, these cancel out. So really, what we're left with is the limit as x approaches infinity of e to the 1 over x power. But once again, right, when you plug in infinity here, okay, 1 over infinity is very close to 0, and e to the 0, right, anything to the 0 power is equal to 1. So that's what this limit is going to equal.